A very good morning to all the students. I am Dr. HimaBindhu from the Department of Mechanical Engineering, and I'll be dealing the robotics subject. And my today's topic is problems on few of the manipulators. Right? Coming to the first problem, let us see. Let me read the question first. For the vector v is equal to 25i plus 10j plus 20k, perform a translation by a distance of 8 in the x direction and 5 in the y direction and 0 in the z direction, right? X, y and z. At x it is traveling at 8, at y it is traveling at 5, and at z it is traveling at 0 direction. So we need to find out the performance of addition. We need to find out what is the overall constraint, right? So to perform the translation of the vector is being given with v is equal to 25i plus 10j plus 20k, where it is taking a distance of 8 units in x direction, 5 units in y direction, and z units, 0 units in z direction. That is, at z direction it is simply 0. So you simply add the translation amount of the corresponding component to the vector. That is, translation is nothing but t is equal to 8 units in the x direction 8i plus in y direction it is 5 units, so 5j, plus in z direction it is 0, so it is taken as 0k, right? When we come across the translation vector is equal to, already we have 25, so 25 plus 8 into I plus 10, this 10 plus this 5 into j plus 20 the unit of the vector z, that is 20 plus 0 into k. When we add this, we are getting the translation vector as 33i plus 15j plus 20k. So the translated vector is nothing but 33i plus 15j plus 20k. Clear? This is how we calculate the translated vector for a given vector with the given units. Right? Hope you have understood. Moving on to the next problem. For the point 3i plus 7j plus 5k, perform the translation of 6 units along y-axis and then rotate 300 degrees about x-axis, right? That is, at y and x-axis, what is happening here? We already have the vector here, that is 3i plus 7j plus 5k. Perform the translation of 6 units along y-axis. Along y-axis it is taking 6 units, and along z-axis it is taking a rotation of 300 degrees. So here x-axis we are not having, but here we have got x-axis, that is x comma y comma z is equal to 3 comma 7 comma 5 from this particular vector, right? So here x is nothing but x is equal to 3, y is equal to 7 as per this, and z is equal to 5. But here what we have, y is taken as 6. So we will be adding 6 plus 7. So how much we have got? Y is equal to 13. So x is equal to 3. X is equal to 3, y is equal to 13, and z is equal to 15 as per our given translation. Now, we have told that the x-axis is rotating at some particular angle. That is, we have told that x-axis is rotating at 300 degrees, right? So, when we come across the rotation axis, we will be writing the rotational matrix, which we have seen in the module 2, right? So, as per the rotational matrix, what is the constraint? 1, 0, 0, 0, 0, cos theta minus sin theta Sine theta and cos theta, that is as per the rotational matrix. This is the matrix which we will be getting. But here what is theta? It is nothing but 300 degrees. Right? When we write that in form of radians. Right? How do we write? 300 degrees is equal to 300 pi by 180. Right? What is 300 pi? It is nothing but when we cancel this, what we get? 5 pi by 3 radians. Right? When we are considering it in form of radians. Now calculate the cos and sine of that particular 5 pi by theta, because here we have cos theta and sine theta. So when we are calculating the cosine and sine in terms of 5 pi by 3, what we are getting? Cos of 5 pi by 3 is nothing but sine of 360 minus 60, which is nothing but cos minus 60, which is nothing but cos 60 degrees is pi by 2. Cos 60 degrees is nothing but 1 by 2, as we all know. Now when we come across sine 5 pi by 3 is equal to sine of 360 minus 60, which is equal to sine of minus 60 degrees is equal to sine minus 60 is nothing but root 3 by 2. That is sine 60 degrees. Now when we are writing that in terms of matrix, what we will be getting? 1, 0, 0, 0, 1 by 2, 0, root 3 by 2, minus root 3 by 2 and 1 by 2. Now the same we have written here into x, y and z, because we already have these vectors, right? The rotation matrix into x, y and z. So what we will be getting here, which is equal to 1 here, see here, 1 into 3 plus 0.13 plus 0.5, and next is 0.3 plus 1 by 2 into 0.3 into 13 plus root 3 by 2 into 5, right? Into 0.3 minus root 3 by 2 into 13 plus 1 by 2 into 5. This is also into 5, right? So what we have got? 3. 0.5. Right? So what is the final matrix which we have got? 3, 13 plus 5 root 3 by 2 and minus 13 root 3 by 2 plus 5. That is the constraint which we have got. Right? So now, thus the final coordinates of the point after translation and rotation are 3, 13 plus 5 root 3 by 2, or 5 minus 13 root 3 by 2. That is the constraint which we have got. Right? So this is about the problem which we have solved for the second module. Right? Now next, coming to the third problem, we need to develop the resultant rotation matrix that represent a rotation of pi angle about OY axis, followed by a rotation of theta angle about the OZ axis, followed by a rotation of alpha angle about the OX axis. That is, we are considering two axes, OX, OY and OZ. Right? Now we need to find out these particular angles. Right? Develop the resultant rotation matrix that represent a rotation of pi angle about. Here we are considering pi angle for OY, and for OZ we are considering theta, and for OX we will be considering alpha. So considering these angles, we need to solve the rotational matrix, right? So how will we solve the rotational matrix here? That we have to do. So let us first, so here what we are doing, how do we solve? First we need to take the rotation Ry of pi first we need to consider, which is equal to cos phi 0 sin phi 0 1 0 or sin phi 0 cos phi. Right? This is the first constraint. What is the second constraint? With respect to Rx. Rx of pi is equal to 1 0 0 0 cos alpha sin alpha 0 minus sin alpha into cos alpha. Right, these are the two considerations, rotational axes which we have considered with respect to y-axis and the z-axis. Right, to obtain the result, to obtain this particular result, now we need to compute rz of theta into rx of, right. So how do we write this particular equation now? So first one, compute rz of theta into rx of alpha, right? That is rz theta into rx alpha is equal to cos theta minus sin theta and 0 sin theta cos theta into 0 0 0 1 with this is with respect to z 1 0 0 0 cos alpha minus sin alpha 0 sin alpha and cos alpha is with respect to x. So what is the final equation which we get? Cos theta into minus sin theta cos alpha into sin theta sin alpha. That is here. When we are multiplying both the equation matrices, cos theta cos alpha minus cos theta sin alpha 0 sin alpha cos alpha. This is the final equation which we are getting when we are multiplying these particular two equations. Right, now we need to compute. Ry of pi with respect to rz of theta into rx of alpha. That is, with this we need to compute ry. So what is ry of pi into this particular equation, right? So what will we get here, right? What is ry? Cos pi 0 sin pi 0 1 0 minus sin pi 0 cos pi into cos theta minus sin theta cos alpha sin theta sin alpha sin theta cos alpha minus cos theta sin alpha 0 sin alpha and cos phi. When we are multiplying these two, what is the final equation which we get? Cos phi cos theta plus sin phi sin theta sin alpha into minus this one when we are considering minus cos phi sin theta cos alpha cos phi sin theta sin alpha plus sin phi cos theta. Next one is sin theta cos alpha into minus cos theta sin alpha. And this one when we are considering minus sin phi cos theta plus cos phi sin theta sine alpha, sine phi, sine theta, cos alpha, minus this one I'm writing here, minus sine phi, sine theta, sine alpha, plus cos pi into cos theta. This is the final matrix which we have got when we are multiplying, right? Thus, here when we are doing all this, the resultant matrix, rotational matrix, we need to find out the rotational matrix, right? So the resultant rotational matrix which we get will be R is equal to cos pi cos theta plus sin phi sin theta into sin alpha sin theta minus cos pi sin theta cos alpha cos theta cos alpha cos pi sin theta sin alpha plus sin pi cos theta minus cos theta sin alpha, and third matrix will be minus sin phi cos theta plus cos pi sin theta sin alpha, and this will be sin phi sin theta cos alpha and minus sin phi sin theta sin alpha plus cos phi and cos theta. This is the final resultant matrix which we will acquire about the OZ at angle theta, OX at angle alpha, and OY at angle phi. So this is the final rotational matrix which we will be acquiring at these particular angles. Clear? Yes? Let me explain once again. Since here we have given as three axes x, y, and z. So here at OZ it was considered as, at OY it is considered as phi, at OX it is considered as alpha, and at OZ it is considered as theta. So considering these particular angles, we need to write the rotational matrix. So first we have considered Ry of pi, Rx of alpha, and then we have calculated Rx of alpha into Rz of theta, and we have got the final matrix, right? Rotational matrix. Clear? Hope you have understood about these three problems, where two were based on the vector geometry problems with respect to x, y, and z axes, and one is the rotational matrix problem. How we write the rotation matrix when OZ, OY, and OY, OZ, and OX axes are being given with respect to theta, alpha, and phi. Right, and these are the differences which we have gone through. So this is all for today's class, and in the next class we will be dealing with the other two problems based on the manipulators. Right, signing off for today, Dr. G. HimaBindhu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.